Hello my friends of Qatari Labs, my name is Saul Montoya. Please welcome to this tutorial on seawater intrusion modeling with Modflow 6 and Model Muse and Flopy. We are going to use the latest version of Modflow 6, not really the latest, but the one that implements the Buoyancy package that can model seawater intrusion. And let's start. Okay, you are going to receive on the description of the video this folder. Okay, and here I'm going to close this. And on this folder, what we are going to do is please place it under your documents, and let's open here Anaconda prompt, and then cd documents cd dir cd example of seawater intrusion modeling with Modflow 6 and the Buoyancy package, and then here you can type Jupyter Lab, or but in my case doesn't work, so I have to type Python Jupyter Lab. That is the same. Okay, great. Let's have a review, because on the tutorials or the material that I want to develop in Modflow and Model Muse, my main purpose is to use Model Muse as long as possible. Why? Because the working in Flopy is more abstract, and I'm really deep into increase the number of people that actually use the tool. Okay, not actually that you become an expert on the tool, but actually you have great steps into knowing the tool. That's why by using a graphical user interface, we can see, and then we have a clear sense of what is going on with the model, or how the model is constructed. And then for the parts that we cannot do it with Model Muse, we are going to use Flopy. Okay, so here we have a model. We have for example, here I'm going to delete everything except of the GPT, because the first step is to show you the model that we have prepared. Okay. Uh, okay, this is a simple model of 5 layers. We have general head boundary condition of 3 meters. And then here what we have is the sea, and the sea has it's also a general head boundary condition of 0 meters of elevation. Okay, and this general head is and then we have a well here, and the well is pumping on the second time step and 2000 cubic meters per day. Okay, great. So what else will we have here? Let's go to Modflow time. On the Modflow time, we have two stress periods, one of 5,000 days and the other of 5,000 days, both in steady state. However, you can do it as well in transient. I mean, there is no difference on that. And then every step we have divided, every stress period we have divided in 20 time steps. Great. What else do we have here? Okay. Okay, the well is not on the first layer. The well is on the 5th layer. Okay, and then if we run the model, we can run the model, and actually it's required that you run the model before doing anything else, because what you are going to do with Flopy is to import this flow model. Okay, great. So let's have a check on the water balance at the end. So we have the general head. From the general head, mostly goes to the well, and then the rest goes to the sea. Okay, so, and this is something that we wanted on purpose, because in order to have seawater intrusion, the amount of pump has to be significant from the water table. I mean, if you have, for example, the inversion, you have 300 cubic meter per second and the GHB of 2000, actually you are not going to see much seawater intrusion. Okay, great. Great. So here we have the boundary. We are not going to import the results. You can do it, but actually we are not going to import those results. And this is the Jupyter Lab. Maybe you might have like this. Okay. And then here what we are going to do is we go to model by. Okay. And then, well, I'm going to do a new notebook. However, you can do it by your own. I mean, the all the script is here in the one that is here, but I think that I can do it step by step in order to show you. First, we import the required package. Okay, that's it. Then we import the Modflow 6 model and then explore the package. Okay. And then, okay, so here we define the model, then the executable, we load the model, and then we change the working directory. Why we change the working directory? Because actually it's a mess, since you are importing a model and then you are adding, you import a Modflow 6 model, and for that Modflow 6 model you apply a transport model. Okay, you are importing a Modflow 6 simulation, so that's why we have a simulation that has a flow model. Okay, but then you add to that a transport model under the same simulation, so you will have a mess of paths. Okay, because actually this can, if we don't change the sim path, actually this can you can do changes on your flow path. Okay, so it's better to have a copy. Actually, that is actually not a copy. Why is actually not a copy? Because you will see later on the mfsim.num that that you have changed some of the paths, not all the paths. But however, it works well. Okay, but it's something that that we have to take into consideration. So we have imported, we have changed the the sim path. Okay, don't worry. Okay, we can get the package list like this. For example, if you want to see, those are the package lists that you have. This is more, under the simulation you have the temporary discretization and I think that this is not a function. No, this is just a property. Okay, you have the simulation and the EMS and as well the exchange. Okay, well, this is so much Modflow 6. Okay, then we import the flow model. Okay, under simulation, remember that in Modflow 6 you have the simulation, and then under the simulation you have many models, so you import the Modflow model. Okay, and then from the Modflow model we have to set the relative path as well. Why? Because otherwise, you change. Okay, just follow me that you have to do that. Okay, it has a logic in the end. Okay, and then we can have the package list of the Modflow model. Okay, of the flow model. Okay, and this is where we have the GHB, the well, and the other ones. Okay, we can get a representation of the model geometry to see that we have imported that correctly. So this is the representation model top and all the bottoms. But as well we can do some plots. Okay, we can do an aerial plot here. Okay, this is an aerial plot, and as well we can do a cross section, and this has to be the same as this and this. Okay, this homework for you. Great. And then we can review the boundary conditions. For example, the general head boundary, and this is the general head boundary. So we have here the sea, and this is the regional flow. And as well on row number 5, yeah, row number 5, because actually this one starts from 1, I guess. So we can have this, and this is the well. Okay, and as well this one. Okay, Great. Then we can, okay, this is, we have to add a auxiliary, okay? Okay, if you want to set up, I mean, if you want to do, density, variable density modeling or seawater intrusion, what you have to do is you have to define auxiliaries into the boundary condition. For example, in this case, we are going to define auxiliary of the GHB that is going to be concentration. Okay, and that's how it works. And you need that in order to enable uh, the buoyancy package. Okay, the buoyancy package is the one that allows you to model variable density model. Okay, so we have the concentration of the salt, we have the freshwater concentration, we have the density of the salt seawater, we have the density of fresh water, and then we have the slope. Okay, and then we say, okay, from 0, well, those are actually 0, and this is the, because 0 means this one. Okay, this is the initial, this is the slope, and this is, what is this? Oh, and this is the buoyancy, and the auxiliary is concentration. Okay, and the dense reference is 1000. Okay. Okay. This is 0, but this is integer. Why? Because you can, in this model, you can define many elements or like components that can create density. For example, seawater is concentration of sodium chloride, but it can be as well as potassium chloride as well. So you can add many special chemical species. Okay, but in this case, okay, this is the slope, and when this is the starting point, I guess. Okay, great. Yeah, the slope and x0, y0, y0, x0, well, whatever. Okay, you can review the concentration. Right, so this is, we have just one species that that we have to take into account for the variable density. Okay, that's it. Okay, then we can define our transport model. Then we can define our and register our solver for the transport. Okay, in this case, this is more clear that it was what it was in Modflow in the previous version, because the transport and the flow works really similar. Okay, so in previous versions actually was not that clear, but okay, at least in my opinion. Okay, so we have the discretization here. That's amazing. And then we have the starting concentrations. Why we have a starting concentration? Because at the beginning, okay, we have seawater. I mean, we have at least that all of these two columns are with seawater at least. Okay, because actually, yeah, you have, I mean, you have the normal seawater intrusion, and as well you have the intrusion that comes from the pumping. Okay, so here this is the initial condition. So at the beginning, the concentration, we say that the concentration of these two columns over all the rows is 35. Okay, so we can make we can show you the concentration 0 and 35, and then here we can define advection. We have to define dispersion. Okay, and then the dispersion requires these variables of dispersivity, like this is the molecular dispersivity, and this is the dispersivity of the flow of the this is the dispersivity um, of the porous media. Okay, horizontal, vertical, and horizontal, transverse, horizontal. Okay, great. So then we have the mobile and storage aquifer. We have to define that as well, because this allows us to insert up the porosity. Okay, we have to run this, because otherwise I think that there won't be porosity. Well, interesting. I mean, you can play around what, and this is really funny to see what happens if you disconnect any of them. And then here you have sink and source package. Okay, so you have to define the sink and source, because the C will be a source. Okay, and it will be through the concentration. Okay, okay, I tried that just to set up, because it was possible at the beginning, just to set up a concentration, initial concentration on the GHB, and then run the model, and then you will have the C always pouring or giving the same concentration. However, what I found is that when you run the model in Modflow 6 with the Buoyancy package, the constant concentration on the C is not constant. I mean, it's like in the beginning it has 35, but when the with time the concentration decreases on the C, and then you know that the concentration won't decrease on the C. So that is why we have to use innovative constant concentration package. Constant concentration package, okay? And this we apply that for the cells that are defined as C, okay? And then we define this constant concentration, and this constant concentration, as it says, it will give, I mean, all the cells that come from the C will have the same concentration all over the time, as long as you have it. Okay, great. Then we have define the output control. We have to define the output control. Okay, and then we define the exchange. Okay, we have to define the exchange. And what does it mean, the exchange? Because the transport model, that is actually the transport of salinity on seawater, will affect the flow model. So that's why you have to define exchange in order to make the link among them. Okay, I mean, if you don't have the buoyancy package, this exchange actually is just to say that and I think that is the transport model is coupled with the flow model, but now in this exchange is that actually transport model will have an influence on the flow model, and vice versa. Okay, so we can run the model, we can write the model and run the model. Okay. Yeah, something that is missing here is the executable. So I will put it in there. Okay, and here it will be like this. Okay, so kernel run all cells. Okay, don't worry. It's the same, it's the same, it's the same, it's the same, it's the same. And okay, and that's it. And then it has some, and I think that this comes from Model Muse, so it has some discrepancy, but this is from the EMS. You can play around with that. Actually, it works for me, it works, so I'm not very concerned of fixing this error. Okay, so it has run for all of them. And then we can open the heads and the concentration. So we open concentrations, and concentration in Modflow 6 is a head file, so actually it's not as a UCM file. I mean, it's a UCM, but it's not an empty 3D file. It's a head file, and the BHD is also as a head file. Okay, and then we have this is for the second stress period, and as well, because this is just the latest 5, but we have also for the first one. So let's have a look on the late of the first one where there is no pumping. Okay, so here, and then here we are going to plot the heads on row 1. So actually it will be just a flow from the regional flow to the sea, nothing to, and this is the effect of the variable density. Okay, because actually if there was no variable density modeling, this has to be the same. Okay, or not the same, but actually you even have to you even have an ascending flow path. Okay, great. And then here we have the concentration on layer 5. Okay, and on row 5. Okay, but there is no well, so actually we see the natural seawater intrusion. The natural seawater intrusion as well here has some related to the dispersion. Okay, and as well here we can see the heads, the contours, and the heads and the concentration on layer 5. So on layer 5. Okay, so and then we see the regional flow, and as well the concentrations are the same. Okay, so but let's change for the end of the 5,000 days of pumping, so the end of the second stress period. Okay, so here we see the well, so the well is actually decreasing heads. Okay, on the has a lower head because actually this is a water goes to the well. We see the plot concentration on layer 5, so we see how it has intruded. Okay, but not only in this one, as well on the first layers. But the concentration is around 4, something like that. And then here we can see the flow paths. Okay, we see the cone of depression of the well, and as well the different concentrations that arrive to the well. And then we see that there is a gradient from this direction and as well in this direction. Okay, so this is the example. I hope that it will be helpful for you. We took some time to develop this, but because it's actually a new way to do transport modeling. The advantage is that everything is under the same executable, or that is means Modflow 6. However, and the code is actually new because Seawater was actually working with Modflow 2000. The disadvantage is that the way that you work with the transport model is new. Okay, so you have to take that into account on your mind, because otherwise you are going to have troubles working with the you won't have much tutorials or documentation, and most probably you won't find anyone to ask about how it works. Okay, most probably. Okay, so that was everything from me. Please follow us in our social networks. Thank you for following this video, and we hope that we can see you in coming tutorials. Have a great day. Bye. Bye. All files will be attached to the description of the videos.